Hello, this is a section 4.2 linear square regression. So finding an equation that describes the linearly related data. So we're going to use the following the data set. So x is going to be the number we have here and the y is the number we have here as a relation. Okay, so A, finding a linear relation that relates x in an explanatory variable and the y is a response variable by selecting 2 points. Finding the equation of the line containing the points. So this is arbitrary. So I want to choose any 2 points. So I'm gonna use from the table. I am using as 2 and 5.7, and then 6 and 1.9. So since this is a linear equation, so I want to solve for solve for a slope, which is 1.9 minus 5.7, and 6 minus 2. And then I got the negative 0.95. And also using a slope intercept form. Okay, so y sub 1, I use a 5.7. Slope is negative 0.95 times by x minus 2 as x sub 1. And then I want to solve for y. I got negative 0.95x plus 7.6. So this is actually the equation we found from the table. Okay, now what I'm going to do is I'm going to grab the equation on the scatter diagram. So I'm going to plot it in. So 0, which is about 5.8. And 2 about 5.7. And 3 about 5.2. 7 over here. And then 5 is 2.8. And then 6 is a 1.9. And another 6 is a 2.2. Okay, so about here. So I just plotted in. And then, so this is actually the scalar plots from the table. And also I'm gonna grab this equation too. So minus 7 is, I'm using different color. 7.6 is about here. And then x intercept, when you set y equal to 0, and then solving for x, and then I got the x equal to 8 right here. And then I'm gonna actually making a straight line going through these two red points. So I got this. So now what I got is, okay, so now we need to use the equation to predict the y, that is a x equal to 3, because x is a 5.2, but let's see what we're going to get from the equation. So y equal to, plug it in, negative 0.95 times by 3 plus 7.6, and then I got 4.75. So there is actually a difference between the 4.75 and then 5.2. Okay, all right, let's look at the next question. So now we can talk about the residual. So the difference between the observed value of y and the predicted value of y. Okay, so predicted value of the y you get from the equation using 2 points from the table. Observed y is from the table. So using the line from the last example, the predicted value at x equal to 3 was, which is 5.2, and then predicted value comes 4.75. So we got this is a much of the difference. So that's we call the residual. Okay. So least square regression criterion. So least square regression line is a line that is minimize the sum of the square error of the residual. And this line minimizes the sum of the square vertical distance between the observed value y and those predicted by the line y hat. We represent that as minimize the sigma of the square of the residual. So the least square regression line, the equation we get to this one. So instead of just pick the 2 points and then we try to actually find out this way, okay? So B1, which is like a slope, r times sy s of x, and the y-intercept b sub 0, like a y bar minus b sub 1 times x bar, is a y-intercept of the least square regression line. So x bar is a sample mean, x sub x is a sample standard deviation, and the y bar is a sample mean of the y, s of y is a sample standard deviation. All right, so let's look at the number 2. So in the number 2, use the drilling data, which is we just had it. So find the least square regression line here. So we already found it as on the previously. So x bar was 126.25. Y bar was 6.985833. R was 773, sorry. And S of x is 52.22874. And S of y is 0.780774. So in order to find the y hat, which is b1 x plus b sub 0. So in order to find the b1 is r times s of y over s of x, which is 0.773 times by 0.780774 divided by 52.22874. And then I get that as about 0.0116. And then b sub 0, I got y bar minus b1 and x bar. And then 6.985833 minus 0.0116 times 126.25. And then I get about a 5.5213. Now I can plug it in. So y hat is going to be b1, which is 0.0116x, plus b sub 0, which is 5.5213. Okay, so this is what I do. And so predict the drilling time. If the drilling starts at the 130 feet, so this time y hat is about time to find. So 0.0116x plus 5.5213, and then you plug it in the drilling 130 feet and add it to 5.5213, and then you got 7.0293. Okay, so that about the 7-minute takes. All right, is that the observed drilling time at the 130 feet above the below the average? So okay, so you observe drilling. Okay, sorry, let me write that again. Okay, observe drilling time is 6.93 seconds, and the predicted drilling time is 7.035. Is it minutes or seconds? Hold on a second. It's a minutes. What did I say? Seconds here. Sorry about that. It's a minutes. So drilling time. Time of 6.93 minutes is the below the average. Okay. And then D, draw the least square regression line on the scatter diagram on the data. So if I use the table that what we have here, so 35. So let me label for the x as depth in feet, and the y is the time in minute. Okay, and then the mark is, I want to say 40, 80, and 120, 160. Okay, other one, it was 6, 7, 8, 9, and 10. Okay, all right, so when we get that, we have 35. So this is so 35 is about, this is actually the 20. So 20, so 35's about here to get the 5.88. So it's about here. And then 50. So 50 is about here because it's 60. So 50 is about here to 5.99. And then the 75. So 75 is about here and 6.74. And then 95. So 80, 100, 95 is about here. Is a 6.1. And then 120, it's about 7.47. And then the 130, it's about 6.93. And then 145, about here, 6.42. 6.5, right? So about here. And then 155, which is 155 is about here, 7.97. And then 160 is 7.92. And then 175. So this is 180. So 175 is about here, 7.62. So about here. And then 185, which is 60, and 180 should be, this is actually the every 4, so the 200 here. So 180 is about, this is 180, so 180 is right here. This is 6.89. And then also 190 is, which is so about here. And then 7.9. So about here. Oh, it's a little bit low here. Okay. And then if I actually grab this from the y hat we have, so y hat was 0.11, 0.0, right down here. So y hat was 0.0116x plus 5.5213. And then if I actually put in, so the y-intercept is about 5.5. Wait, this is a 5.5, so it's about here. And then if I plug it in 190, it's about here. And then come out as 190 to plug it in. Then I get about 0.0116 of 190 plus 5.5213. And then so 0.0116 times by 190 plus 5.5213. I got about 7.7253. So 180, 190. So it's about 7.7253. 7.7, which is a little bit below here. And then I can just put the line together straight. Okay, so that's all. Okay. All right, so thank you for listening.